Okay, so this one has a fraction. I know everyone loves fractions, but it's a cubic function, right? And let me bring out my list of things we can use, right? Our kind of checklist for our graph here. So again, I have that first one on the list, even though it's not going to be very surprising every time. That's fine with me. But our domain is the set of real numbers, right? Our leading coefficient test, this would be our leading term, right? So we are an odd degree, but we're negative, which means that the left side is up and the right side is down. And that's opposite of what we saw in the last one. So those two are done. Let's focus on rational zeros. So if we do that, that means, so this is our, or excuse me, our real zeros. Real zeros. That means we take g of x and we set it equal to 0. And this is where you kind of have to remember some of your old factoring techniques. So we've got negative 9 over 2x plus 6x squared minus 2x cubed is equal to 0. Now, what we typically do here, because there's an x in every single term, right? We have x, x, and x. What we typically do is we factor out an x. And you know, I'm even going to take a negative with me because I have my leading term negative. The other thing I'm going to do, though, is I'm going to take a 2 with me. Excuse me, a 1/2. Because this 1/2 makes this kind of an awkward setup, right? And in fact, before I even do that, let me reorganize this. So negative 2x cubed plus 6x squared minus 9/2 x is 0. So I'm going to take a negative 1/2 x out of the mix. Okay, so what that does, when I divide by 1/2, it essentially means I multiply by 2, right? Divide by 1/2 means multiply by the reciprocal. So I'm going to actually multiply our first two terms by 2, negative 2. And so this becomes 4x squared. This is the factoring process, right? Minus 12x plus 9. Now, I don't know that that's always intuitive. That's why I go over an example like this so that you can see what we did and why we did it. But also, I want to point out that if you were to distribute this back, you would go back to your original question. Okay. What I do not necessarily encourage is I do not necessarily say, oh, just multiply everyone by 2. The reasoning for that is I don't even really have to set this equal to 0 yet. You could just be using g of x's notation throughout this whole thing. And it wouldn't make sense for us to multiply this g of x times 2. So it's one of those differences between an equation versus a function, right? With a function, we typically only deal with the one side at a time. Everything seems to be very self-contained. So I just want to kind of keep that in mind. Okay, so we have this polynomial. We actually can continue to factor this. This is actually a perfect square trinomial. If you don't see that, that's okay. Use your own factoring techniques. But again, I do want to see your techniques that make sense. I do not want to see Photomath or Chegg or whoever else. So this is going to give us negative 1/2 x is equal to 0. This is the zero product property. And then this is going to give us 4x squared minus 12x plus 9 is 0, which, like I said, factors 2x minus 3 squared is equal to 0. This one again says x is just equal to 0, and the degree out here was 1, so this is multiplicity 1. There's one of your real zeros. Here, notice it's squared, so we are going to have multiplicity 2, but we can square root both sides. And this essentially gives us 2x minus 3 is 0, 2x is 3, and x is 3 halves. And this has multiplicity 2. So just like we saw in the last question, we're going to have a point of tangency here. So it's going to touch that point and then return back in the same direction. And then this one, because it's an odd multiplicity, will cut through it somehow, right? It'll actually cross. So let's take a moment and let's actually, let's also find the y-intercept. And that means we're finding f of 0. So f of 0, again, I reference back to the original one because everything's distributed already, right? So this is negative 9 over 2 times 0 plus 6 times 0 squared minus 2 times 0 cubed, cross that off, which is still just 0, right? So our y-intercept is 0, 0. And lucky for us, that agrees with what we already saw, right? So nothing new in that exact moment. Okay, so now we want to break out our graph. While I'm doing that, I'll just point out, right, our pieces or kind of components that go into this graph, right? This list of steps, it is something you should know. It is something you should pretty much follow. There's only, tiny bits of wiggle room as we go through this. But also I want to point out, make sure that these pieces are something, we can find, right? So I can clearly see what the zeros are. We can even label, right? Real zeros slash x-intercepts, right? They're labeled, it's clear to see. We can see what that y-intercept is. We can see what the domain is, what our end behavior looks like thanks to our leading coefficient test. So just make sure each of those elements are easily found. I'm going to go ahead and graph each of these. Okay, so what additional points do we need? Well, we need to know, we have a rough idea, but we need to know exactly what's going on the left of that first point. So anything in this kind of region over here. So let's go ahead and do that. We have x and we have g of x, negative 9 over 2x plus 6x squared minus 2x cubed. And let's set up a table. Tables are helpful, or you can do it like we did the very first question where you just kind of write them out. You have options. So something that lives on the left of that, let's try negative 1. Let's try that right there, negative 1. So if we plug that into our function, we've got negative 9 over 2 times negative 1 plus 6 times negative 1 squared minus 2 times negative 1 cubed. So this becomes positive 9 over 2. This is just positive 1, right? So plus 6. And this becomes negative 1 times negative 2 gives us plus 2. 6 plus 2 is 8. So 9 over 2, this is 8, right? If I put 8 over 1 and I multiply times 2 times 2 times 2, that gives us plus 16 over 2, which gives us 25 over 2, which is 12 and a half, right? So again, it's a little out of kind of our boundaries here, but that wouldn't be a big kind of estimation, right? It'd be just above where our graph sits. So maybe a point like right there would be fair. Okay, let's try another point between 0 and 3 halves. I'm going to plug 1 in. So if we plug in 1, we've got negative 9 over 2 times 1 plus 6 times 1 squared minus 2 times 1 cubed. So this is negative 9 halves plus, this is just 1, right? So plus 6 minus 2, negative 9 halves plus 4. And 4 over 1 is going to be 8 over 2, right? We're going to say times 2 times 2. Let me actually just write that in. And that gives you negative 1/2. So you can see kind of opposite of our last question. This one does not go very low. If you're questioning that, you can plug in something like a 1/2 if you want. But we do have this left side up. We're going to come down through this point and back up. And remember, we have a point of tangency here. So I'm expecting my last point over here on the right side of that point, that 3/2 to be down below. So let's try 2. 2 is immediately to the right of that. Negative 9 over 2 times 2 plus 6 times 2 squared minus 2 times 2 cubed. So these first pair of 2's are going to cancel. And you're just left with negative 9 plus 2 squared is 4, and 6 times 4 is going to be 24. And then 2 times 3, this is really essentially 2 times 4, right? This is a negative 16. So this gives us a negative 1. Right there. So let's see if we're able to essentially connect these points and get a decent graph out of it. Something like that. Okay?